If you're a DevOps guy, then you would have definitely heard of Kubernetes. But I don't think the DevOps world knows enough of what exactly Kubernetes is and where it's used. And that's why we at Edureka have come up with this video on what is Kubernetes. My name is Vardhan, and I'll be representing Edureka in this video. And as you can see from the screen, these will be the topics that I'll be covering in today's session. I'll first start off by talking about what is the need for Kubernetes. And after that, I will talk about what exactly it is and what it's not. And I will do this because there are a lot of myths surrounding Kubernetes and there's a lot of confusion. People have misunderstood Kubernetes to be a containerization platform. Well, it's not. Okay, so I will explain what exactly it is over here, and then after that I will talk about how exactly Kubernetes works. I will talk about the architecture and all the related things. And after that, I will give you a use case. I will tell you how Kubernetes was used at Pokemon Go and how it helped Pokemon Go become one of the best games of the year 2017. And finally, at the end of the video, you will get a demonstration of how to do deployment with Kubernetes. Okay, so I think the agenda is pretty clear to you. I think we can get started with our first topic then. Now, first topic is all about why do we need Kubernetes. Okay, now to understand why do we need Kubernetes, let's understand what are the benefits and drawbacks of containers. Now, first of all, containers are good. They are amazingly good, right? Any container for that matter of fact, a Linux container or a Docker container or even a Rocket container, right? They all do one thing. They package your application and isolate it from everything else, right? They isolate the application from the host mainly. And this makes the container fast, reliable, efficient, lightweight, and scalable. Now, hold your thought. Yes, containers are scalable, but then there's a problem that comes with that. And this is what is the resultant of the need for Kubernetes. Even though containers are scalable, they are not very easily scalable. Okay, so let's look at it this way. You have one container, you might want to probably scale it up to 2 containers or 3 containers. Well, it's possible, right? It's going to take a little bit of manual effort, but yeah, you can scale it up. You're not going to have a problem. But then look at a real world scenario where you might want to scale up to like 50 to 100 containers. Then in that case, what happens? I mean, after scaling up, what do? You have to manage those containers, right? You have to make sure that they're all working, they're all active, and they're all talking to each other. Because if they're not talking to each other, then there's no point of scaling up itself. Because in that case, the servers would not be able to handle the loads if they're not able to talk to each other, correct? So it's really important that they are manageable when they are scaled up. And now let's talk about this point. Is it really tough to scale up containers? Well, the answer for that might be no. It might not be tough. It's pretty easy to scale up containers, but the problem is what happens after that. Okay, once you scale up containers, you'll have a lot of problems. Like I told you, the containers first of all should have to communicate with each other because there are so many in number, and they work together to basically host the service, right? The application. And if they are not working together and talking together, then the application is not hosted and scaling up is a waste. So that's the number one reason. And the next is that the containers have to be deployed appropriately and they have to also be managed. They have to be deployed appropriately because you cannot have the containers deployed in just random places. You have to deploy them in the right places. You cannot have one container in one particular cloud and the other one somewhere else. So that would have a lot of complications. Well, of course it's possible, but yeah, it would lead to a lot of complications internally. You want to avoid all that. So you have to have one place where everything is deployed appropriately, and you have to make sure that the IP addresses are set everywhere and the port numbers are open for the containers to talk to each other and all these things, right? So these are the two other points. The next point or the next problem with scaling up is that auto scaling is never a functionality over here. Okay, and this is one of the things which is the biggest benefit with Kubernetes. The problem technically is there's no auto scaling functionality. Okay, there's no concept of that at all. And you may ask at this point of time, why do we even need auto scaling? Okay, so let me explain the need for auto scaling with an example. So let's say that you are an e-commerce portal, okay, something like an Amazon or a Flipkart, and let's say that you have decent amount of traffic on the weekdays, but on the weekends you have a spike in traffic. Probably you have like 4x or 5x the usual traffic. And in that case, what happens is maybe your servers are good enough to handle the requests coming in on weekdays, right? But the requests that come on the weekends, right, from the increased traffic, that cannot be serviced by your servers, right? Maybe it's too much for your servers to handle the load. And maybe in the short term, it's fine. Maybe once or twice you can survive, but there will definitely come a time when your server will start crashing because it cannot handle that many requests per second or per minute. And if you want to really avoid this problem, what do? You have to scale up. And now would you ideally keep scaling up every weekend and scaling down after the weekend, right? I mean, technically, is it possible? Will you be buying your servers and then setting it up, and every Friday would you be again buying new servers, setting up your infrastructure, and then the moment your weekday starts, would you just destroy all your servers, whatever you built? Would that what you be doing? No, right? Obviously, that's a pretty tedious task. So that's where something like Kubernetes comes in. And what Kubernetes does is it keeps analyzing your traffic and the load that's being used by the container. And as and when the traffic is reaching the threshold, auto scaling happens, wherein if the servers have a lot of traffic and if it needs more such servers for handling requests, then it starts scaling up the containers on its own. There's no manual intervention needed at all. So that's one benefit with Kubernetes, and one traditional problem that we have with scaling up of containers. Okay, and then yeah, the one last problem that we have is the distribution of traffic. That is still challenging without something that can manage your containers. I mean, you have so many containers, but how will the traffic be distributed? Load balancing, how does that happen? You just have containers, right? You have 50 containers. How does the load balancing happen? So all these are questions we should really consider, because containerization is all good and cool. It was much better than VMs. Yes, containerization, it was basically a concept which was sold on the basis of scaling up, right? We said that VMs cannot be scaled up easily, so we told use containers, and with containers you can easily scale up. So that was the whole reason we basically sold containers with the tagline of scaling up. But in today's world, our demand is ever more that even the regular containers cannot be enough. So scaling up is so much or in so detail that we need something else to manage your containers. Correct? Do we agree there? We need something, right? And that is exactly what Kubernetes is. So Kubernetes is a container management tool. All right. So this is open source, and this basically automates your container deployment, your container scaling and descaling, and your container load balancing. The benefit with this is that it works brilliantly with all the cloud vendors, with all your public cloud vendors, all your hybrid cloud vendors, and it also works on premises. So that is one big selling point of Kubernetes, right? And if I should give more information about Kubernetes, then let me tell you that this was a Google developed product. Okay, it's basically a brainchild of Google, and that pretty much is the end of the story for every other competitor out there, because the community that Google brings in along with it is going to be huge. Or basically the head start that Kubernetes would get because of being a Google brainchild is humongous, and that is one of the reasons why Kubernetes is one of the best container management tools in the market, period. And given that Kubernetes is a Google product, they have written the whole product on Go language, and of course now Google has contributed this whole Kubernetes project to the CNCF, which is nothing but the Cloud Native Computing Foundation, or simply Cloud Native Foundation, right? You can just call them either that, and they've donated their open source project to them. And if I have to just summarize what Kubernetes is, you can just think of it like this. It can group like a number of containers into one logical unit for managing and deploying an application or a particular service. So that's a very simple definition of what Kubernetes is. It can be easily used for deploying your application. Of course, it's going to be Docker containers which you will be deploying, but since you will be using a lot of Docker containers as part of your production, you will also have to use Kubernetes, which will be managing your multiple Docker containers, right? So this is the role it plays in terms of deployment. And scaling up, scaling down is primarily the game of Kubernetes. From your existing architecture, it can scale up to any number you want. It can scale down anytime. And the best part is the scaling can also be set to be automatic, like I just explained some time back, right? You can make Kubernetes would analyze the traffic and then figure out if the scaling up needs to be done or the scaling down can be done, and all those things. And of course, the most important part, load balancing, right? I mean, what good is your container or group of containers if load balancing cannot be enabled, right? So Kubernetes does that also. And these are some of the points based on which Kubernetes is built. So I'm pretty sure you would have got a good understanding of what Kubernetes is by now, right? A brief idea at least. If you have any doubts, then I would request you to put your comments or queries on the comment section below. All right, my Edureka team will get back to you at the earliest. So moving forward, let's look at the features of Kubernetes. Okay, so we've seen what exactly Kubernetes is, how it uses Docker containers or other containers in general. But now let's see some of the selling points of Kubernetes, or why it's a must for you. Let's start off with automatic bin packing. When we say automatic bin packing, it's basically that Kubernetes packages your application and it automatically places containers based on their requirements and the resources that are available. So that's the number one advantage. The second thing, service discovery and load balancing. There is no need to worry. I mean, if you're going to use Kubernetes, then you don't have to worry about networking and communication, because Kubernetes will just automatically assign containers their own IP addresses and probably a single DNS name for a set of containers which are performing a logical operation. And of course, there will be load balancing across them. So you don't have to worry about all these things. So that's why we say that there is service discovery and load balancing with Kubernetes. And the third feature of Kubernetes is that storage orchestration. With Kubernetes, you can automatically mount your storage system of your choice. You can choose that to be either a local storage or maybe on a public cloud provider such as a GCP or AWS, or even a network storage system such as NFS or other things, right? So that was the feature number 3. Now, feature number 4, self-healing. Now, this is one of my favorite parts of Kubernetes. Actually, not just Kubernetes, even with respect to Docker Swarm, I really like this part of self-healing. What self-healing is all about is that whenever Kubernetes realizes that one of your containers has failed, then it will restart that container on its own, right? It will create a new container in place of this crashed one. And in case your node itself fails, then what Kubernetes would do in that case is whatever containers were running in that failed node, those containers would be started in another node, right? Of course, you would have to have more nodes in that cluster. If there's another node in the cluster, definitely room would be made for this failed container to start its service. So that happens. So the next feature is batch execution. So when we say batch execution, it's that along with services, Kubernetes can also manage your batch and CI workloads, which is more of a DevOps role, right? So as part of your CI workloads, Kubernetes can replace your containers which fail, and it can restart and restore the original state. That is what is possible with Kubernetes. And secret and configuration management. That is another big feature with Kubernetes. And that is the concept of where you can deploy and update your secrets and application configuration without having to rebuild your entire image and without having to expose your secrets in your stack configuration or anything, right? So if you want to deploy and update your secrets, only that can be done. So it's not available with all the other tools, right? So Kubernetes is one that does that. You don't have to restart everything and rebuild your entire container. That's one benefit. And then we have horizontal scaling, which of course you people might be aware of already. You can scale your applications up and down easily with a simple command. The simple command can be run on the CLI, or you can easily do it on your GUI, which is your dashboard, your Kubernetes dashboard, or auto scaling is possible, right? Based on the CPU usage, your containers would automatically be scaled up or scaled down. So that's one more feature. And the final feature that we have is automatic rollbacks and rollouts. Now, Kubernetes, what it does is whenever there's an update to your application which you want to release, Kubernetes progressively rolls out these changes and updates to the application or its configurations by just ensuring that one instance after the other is sent these updates. And it makes sure that not all instances are updated at the same time, thus ensuring that, yes, there is high availability. And even if something goes wrong, then the Kubernetes will roll back that change for you. So all these things are enabled, and these are the features with Kubernetes. So if you're really considering a solution for your containers, for managing your containers, then Kubernetes should be your solution, right? So that should be your answer. So that is about the various features of Kubernetes. Now, moving forward, here let's talk about a few of the myths surrounding Kubernetes. And we are doing this because a lot of people have confusion with respect to what exactly it is. So people have this misunderstanding that Kubernetes is like Docker, which is a containerization platform, right? That's what people think. And that is not true. So this kind of a confusion is what I intend to solve in the upcoming slides. I will talk about what exactly Kubernetes is and what Kubernetes is not. Let me start with what it's not. Now, the first thing is that Kubernetes is not to be compared with Docker because it's not the right set of parameters which you are comparing them against. Docker is a containerization platform and Kubernetes is a container management platform, which means that once you have containerized your application with the help of Docker containers or Linux containers, and when you are scaling up these containers to a big number like 50 or 100, that's where Kubernetes would come in. When you have like multiple containers which need to be managed, that's where Kubernetes can come in and effectively do it. You can specify the configurations and Kubernetes would make sure that at all times these conditions are satisfied. So that's what Kubernetes is. You can tell in your configurations that at all time I want these many containers running, I want these many pods running, and so many other needs, right? You can specify much more than that. And whatever you do, at all times, your cluster master or your Kubernetes master would ensure that this condition is satisfied. So that is what exactly Kubernetes is. But that does not mean that Docker does not solve this purpose. So Docker also have their own plugin. I wouldn't call it a plugin. It's actually another tool of theirs. So there's something called as Docker Swarm. And Docker Swarm does a similar thing. It does container management, like mass container management. So similar to what Kubernetes does, when you have like 50 to 100 containers, Docker Swarm would help you in managing those containers. But if you look at who is prevailing in the market today, I would say it's Kubernetes, because Kubernetes came in first. And the moment they came in, they were backed by Google, and they had this huge community which they just swept along with them. So they have like hardly left any market for Docker and for Docker Swarm. But that does not mean that they are better than Docker, because they are at the end of the day using Docker. So Kubernetes is only as good as what Docker is. If there are no Docker containers, then there's no need for Kubernetes in the first place. So Kubernetes and Docker, they go hand in hand. Okay, so that is the point you have to note. And I think that would have also explained the point that Kubernetes is not for containerizing applications, right? And the last thing is that Kubernetes is not for applications with a simple architecture. Okay, if your application's architecture is pretty complex, then you can probably use Kubernetes to uncomplex that architecture. Okay, but if you're having a very simple one in the first place, then using Kubernetes would not serve you any good, and it could probably make it a little more complicated than what it already is, right? So this is what Kubernetes is not. Now, speaking of what exactly Kubernetes is, the first point is Kubernetes is robust and reliable. Now, when I say robust and reliable, I'm referring to the fact that the cluster that is created, the Kubernetes cluster, right? This is very strong, it's very rigid, and it's not going to be broken easily. The reason being the configurations which you specify, right? At any point of time, if any container fails, a new container would come up, right? Or that whole container would be restarted. One of the things will definitely happen. If your node fails, then the containers which are running in a particular node, they would start running in a different node, right? So that's why it's reliable and it's strong, because at any point of time, your cluster would be at full force. And at any time, if it's not happening, then you would be able to see that something's wrong and you have to troubleshoot your node, and then everything would be fine. So Kubernetes would do everything possible, and it pretty much does everything possible to let us know that the problem is not at its end, and it's giving the exact result that we want. That's what Kubernetes are doing. And the next thing is that Kubernetes actually is the best solution for scaling up containers, at least in today's market, because the two biggest players in this market are Docker Swarm and Kubernetes. And Docker Swarm is not really the better one here, because they came in a little late. Even though Docker was there from the beginning, Kubernetes came after that. But Docker Swarm, which we are talking about, came in somewhere around 2016 or 2017, right? But Kubernetes came somewhere around 2015, and they had a very good head start. They were the first ones to do this, and their backing by Google is just icing on the cake, because whatever problem you have with respect to containers, if you just go up and if you put your error there, then you will have a lot of people on github.com and GitHub queries, and then on Stack Overflow, who will be resolving those errors, right? So that's the kind of market they have. So it's backed by a really huge community. That's what Kubernetes is. And to conclude this slide, Kubernetes is a container orchestration platform and nothing else. All right, so I think these two slides would have given you more information and more clarity with respect to what Kubernetes is and how different it is from Docker and Docker Swarm, right? If you guys still have any doubts, then I would request you to put your comments in the comment section below, and my team will get back to you at the earliest. Okay, so now moving on, let's go to the next topic, where we will compare Kubernetes with Docker Swarm. And we are comparing with Docker Swarm because we cannot compare Docker and Kubernetes head on. Okay, so that is what you have to understand. If you are this person over here, if you are Sam who is wondering which is the right comparison, then let me reassure you that the difference can only be between Kubernetes and Docker Swarm. Okay, so let's go ahead and see what the difference is actually. Let's start off with your installation and configuration. Okay, so that's the first parameter we'll use to compare these two. And over here, Docker Swarm comes out on top, because Docker is a little easier. You have around 2 or 3 commands which will help you have your cluster up and running. That includes the node joining the cluster, right? But with Kubernetes, it's way more complicated than Docker Swarm, right? So you have like close to 10 to 11 commands which you have to execute, and then there's a certain pattern you have to follow to ensure that there are no errors, right? Yes, and that's why it's time consuming, and that's why it's complicated. But once your cluster is ready, that time Kubernetes is the winner, because the flexibility, the rigidness, and the robustness that Kubernetes gives you cannot be offered by Docker Swarm. Yes, Docker Swarm is faster, but yes, not as good as Kubernetes when it comes to your actual working. And speaking of the GUI, once you have set up your cluster, you can use a GUI with Kubernetes for deploying your applications, right? So you don't need to always use your CLI. You have a dashboard which comes up, and the dashboard If you give it admin privileges, then you can use it. You can deploy your application from the dashboard itself. Everything just drag and drop, click functionality, right? With just click functionality, you can do that. The same is not the case with Docker Swarm. You have no GUI in Docker Swarm, okay, period. So Docker Swarm is not the winner over here, it's Kubernetes. And yes, going to the third parameter, scalability. So people again have a bad misconception that Kubernetes is better. It is the solution for scaling up, and it is better and faster than Docker Swarm. Well, it could be better, but yes, it's not faster than Docker Swarm. Even if you want to scale up, right, there's a report where I recently read that the scaling up in Docker Swarm is almost 5 times faster than the scaling up with Kubernetes. So that is the difference. But yes, once your scaling up is done, after that, your cluster strength with Kubernetes is going to be much stronger than your Docker Swarm cluster strength. That's again because of the various configurations that should have been specified by then. That is the thing. Now, moving on to the next parameter we have is load balancing. Requires manual service configuration. Okay, this is in case of Kubernetes. And yes, this could be a shortfall, but with Docker Swarm, there is inbuilt load balancing techniques, which you don't need to worry about. Okay, even the load balancing, which requires manual effort in case of Kubernetes, is not too much. There are times when you have to manually specify what are your configurations. You have to make a few changes, but yes, it's not as much as what you're thinking. And speaking of updates and rollbacks, what Kubernetes does is it does the process scheduling to maintain the services while updating. Okay. Yeah, that's very similar to how it works with Docker Swarm, wherein you have like progressive updates and service health monitoring happens throughout the update. But the difference is when something goes wrong, Kubernetes goes that extra mile of doing a rollback and putting you back to the previous state, right, before the update was launched. So that is the thing with Kubernetes. And the next parameter we are comparing those two upon is data volumes. So data volumes in Kubernetes can be shared with other containers, but only within the same pod. So we have a concept called pods in Kubernetes. Okay, now pod is nothing but something which groups related containers, right? A logical grouping of containers together. So that is a pod. And whichever containers are there inside this pod, they can have a shared volume, okay, like storage volume. But in case of Docker Swarm, you don't have the concept of pod at all. So the shared volumes can be between any other container. There is no restriction with respect to that in Docker Swarm. And then finally, we have this parameter called logging and monitoring. So when it comes to logging and monitoring, Kubernetes provides inbuilt tools for this purpose. Okay, but with Docker Swarm, you have to install third-party tools if you want to do logging and monitoring. So that is the fallback with Docker Swarm, because logging is really important. One, because you will know what the problem is, you'll know which container failed, what happened, where is exactly the error, right? So logs would help you give that answer. And monitoring is important because you have to always keep a check on your nodes, right? So as the master of the cluster, it's very important that there's monitoring. And that's where Kubernetes has a slight advantage over Docker Swarm. Okay, so that's my take on the difference between Kubernetes and Docker Swarm. And I would also love to hear what's your take on this, right? I would like to know if you would use Kubernetes or Docker Swarm, and I would also know why, if you prefer simplicity or if you prefer stability. That choice could be yours, and it's something that's arguable, right? It's a debatable topic. So I would like to hear what are your thoughts. So please drop in your comments at the bottom. We have a comment section, right? Our videos. So put it right there. And probably in one of our future videos, we will discuss about that. But before I finish this topic, there is this one slide I want to show you, which is about the statistics. So this stat, I picked it up from this Platform 9, which is nothing but a company that writes about tech. Okay, and what they've said is that the number of news articles that were produced, right, in that one particular year had 90% of those covered on Kubernetes compared to the 10% on Docker Swarm. Amazing, right? That's a big difference. That means for every one blog written or for every one article written on Docker Swarm, there are 9 different articles written on Kubernetes. And similarly for web searches. For web searches, Kubernetes is 90% compared to Docker Swarm's 10%. And publications, GitHub stars, the number of commits on GitHub, all these things are clearly won by Kubernetes everywhere. So Kubernetes is the one that's dominating this market, and that's pretty visible from this stat also, right? So I think that pretty much brings an end to this particular topic. Now moving forward, let me show you a use case. Let me talk about how this game, this amazing game called Pokemon Go, was powered with the help of Kubernetes. I'm pretty sure you all know what it is, right? You guys know Pokemon Go. It's the very famous game, and it was actually the best game of the year 2017. And the main reason for that being the best is because of Kubernetes. And let me tell you why. But before I tell you why, there are a few things which I want to just talk about. I'll give you a overview of what Pokemon Go is, and let me talk about a few key stats. So Pokemon Go is an augmented reality game developed by Niantic for your Android and for iOS devices. Okay, and those key stats read that they've had like 500 million plus downloads overall and 20 million plus daily active users. Now that is massive. Daily, if you're having like 20 million users plus, then you have achieved an amazing thing. So that's how good this game is. Okay, and then this game was actually initially launched only in North America, Australia, New Zealand. And I'm aware of this fact because I'm based out of India and I did not get access to this game because the moment news got out that we have a game like this, I started downloading it, but I couldn't really find any link or I couldn't download it at all. So they launched it only in these countries. But what they faced, right, in spite of just releasing it in these three countries, they had like a major problem. And that problem is what I'm going to talk about in the next slide. Right, so my use case is based on that very fact that in spite of launching it only in these three countries or in probably North America and then in Australia and New Zealand, they could have had a meltdown, but rather with the help of Kubernetes, they used that same problem as the basis for their success. So that's what happened. Now let that be a suspense, and before I get to that, let me just finish this slide. One amazing thing about Pokemon Go is that it has inspired users to walk over 5.4 billion miles in a year. Okay, yes, do the math. 5.4 billion miles in 1 year. That's again a very big number. And it says that it has surpassed engineering expectations by 50 times. Now, this last line is not with respect to the Pokemon Go, the game, but it is with respect to the backend and the use of Kubernetes to achieve whatever was needed. Okay, so I think I've spent enough time over here. Let me go ahead and talk about the most interesting part and tell you how the backend architecture of Pokemon Go was. Okay, so you have a Pokemon Go container which had two primary components. One is your Google Bigtable, which is your main database where everything is going in and coming out. And then you have your programs, which is run on your Java cloud, right? So these two things are what is running your game. MapReduce and Cloud Dataflow were something which was used for scaling up. Okay, so it's not just the container scaling up, but it's with respect to the application, how the program would react when there are these increased number of users and how to handle increased number of requests. So that's where the MapReduce is the paradigm comes in, right? The mapping and then reducing that whole concept. So this was their one deployment. Okay, and when we say into 5, it means that they had their server capacities which could go up till 5 times. Okay, so technically they could only serve X number of requests, but in case of failure conditions or heavy traffic load conditions, the max the server could handle was 5x, because after 5x the server would start crashing. That was their prediction. Okay, and what actually happened at Pokemon Go on releasing in just those three different geographies is that the moment they deployed it, the usage became so much that it was not X number of times, which is technically their failure limit, and it is not even 5x, which is the server's capability, but the traffic that they got was up to 50 times, 50 times more than what they expected. So you know that when your traffic is so much, then you're going to be brought down to your knees. That's a definite and that's a given, right? This is like a success story, and this is too good to be true kind of a story. And in that kind of a scenario, if the requests start coming in are so much that if they reach 50x, then it's gone, right? The application is gone for a toss. So that's where Kubernetes comes in, and they overcome all the challenges. How do they overcome the challenges? Because Kubernetes can do both vertical scaling and horizontal scaling at ease. And that is the biggest problem, right? Because any application and any other company can easily do horizontal scaling, where you just spin up more containers and more instances and you set up the environment. But vertical scaling is something which is very specific, and this is even more challenging. Now it's more specific to this particular game because the virtual reality would keep changing. Whenever a person moves around or walks around somewhere in his apartments or somewhere on the road, then the RAM, right, that would have to increase. The memory, the in-memory and the storage memory, all this would increase. So in real time, your server's capacity also has to increase vertically. So once they have deployed it, it's not just about horizontal scalability anymore. It's not about satisfying more requests. It's about satisfying that same request with respect to having more hardware space, more RAM space, and all these things, right? That one particular server should have more performance abilities. That's what it is about. And Kubernetes solved both of these problems effortlessly. And Niantic were also surprised that Kubernetes could do it. And that was because of the help that they got from Google. I read an article recently that the head of Niantic's lab, he met with some of the top executives in Google and in GCP, right? and then they figure out how things are supposed to go. And they of course met with the heads at Kubernetes, and they figured out a way to actually scale it up to 50 times in a very short time. So that is the challenge that they were presented, and thanks to Kubernetes, they could handle 50 times the traffic that they expected, which is like a very one-off story, and which is very, very surprising that something like this would happen. So that is about the use case, and that pretty much brings an end to this topic of how Pokemon Go used Kubernetes to achieve something. Because in today's world, Pokemon Go is a really revered game because of what it could, right? It basically beat all the stereotypes of a game, and whatever anybody could have anything negative against the game, right? So they could say that these mobile games and video games make you lazy, they make you just sit in one place and all these things, right? And Pokemon Go was something which was different. It actually made people walk around, and it made people exercise, and that goes on to show how popular this game became. If Kubernetes lies at the heart of something which became so popular and something that became so big, then you should imagine how big Kubernetes or how useful Kubernetes is, right? So that is about this topic. Now, moving forward, let me just quickly talk about the architecture of Kubernetes, and then after that, I'll wrap up the session with a demonstration. Okay, so the Kubernetes architecture is very simple. You have the kube master, which controls pretty much everything. Okay, you should note that it is not like Docker Swarm where your kube master will also have containers running. Okay, so there won't be containers over here. So all the containers will be running, all the services which will be running will be only on your nodes. It's not going to be on your master. And you would have to first of all create your master. That's the first step in creating your cluster, and then you would have to get your nodes to join your cluster. Okay, so be it your pods or be it your containers, everything would be running on your nodes, and your master would only be scheduling or replicating these containers across all these nodes and making sure that your configurations are satisfied, right? Whatever you specify in the beginning. And the way you access your kube master is via two ways. You can either use it via the UI or via the CLI. So the CLI is the default way, and this is the main way technically, because if you want to start setting up your cluster, you use the CLI, you set up your cluster, and from here you can enable the dashboard. And when you enable the dashboard, then you can probably get the GUI, and then you can start using your Kubernetes and start deploying by just with the help of the dashboard, right? By just the click functionality, you can deploy an application which you want, rather than having to write a YAML file or feed commands one after the other from the CLI. So that is the working of Kubernetes. Okay, now let's concentrate a little more on how things work on the node end. Now, as said before, Kubernetes master controls your nodes, and inside nodes you have containers. Okay, and now these containers are not just contained inside them, but they are actually contained inside pods. Okay, so you have nodes inside which there are pods, and inside each of these pods there will be n number of containers depending upon your configuration and your requirement. Right now, these pods which contain n number of containers are a logical binding or a logical grouping of these containers. Supposing you have an application X which is running in node 1. Okay, so you will have a pod for this particular application, and all the containers which are needed to execute this particular application will be a part of this particular pod, right? So that's how pod works, and that's what the difference is with respect to Docker Swarm and Kubernetes. Because in Docker Swarm you will not have a pod, you just have containers running on your node. And the other two terminologies which you should know is that of replication controller and service. Your replication controller is the master's resource to ensuring that the requested number of pods are always running on the nodes, right? So that's like your confirmation or an affirmation which says that, okay, this many number of pods will always be running, and these many number of containers will always be running, something like that, right? So you say it, and the replication controller will always ensure that's happening. And your service is just an object on the master that provides load balancing across a replicated group of pods, right? So that's how Kubernetes works. And I think this is good enough introduction for you. And I think now I can go to the demo part, right, guys? If you guys have any doubts, I would request you to again put it in the comment section, and my team will get back to you. And in the meanwhile, let me get to the final part of this video, wherein I will show you how to deploy applications on your Kubernetes via either your CLI or either via your YAML files or via your dashboard. Okay, guys, so let's get started. And for the demo purpose, I have two VMs with me. Okay, so as you can see, this is my kube master, which would be acting as my master in my cluster. And then I have another VM, which is my kube node 1. Okay, so it's a cluster with one master and one node. All right, now for the ease of purpose for this video, I have compiled the list of commands in this text document, right? So here I have all the commands which are needed to start your cluster, and then the other configurations and all those things. So I'll be using these. I'll be copying these commands, and then I'll show you side by side, and I will also explain when I do that as to what each of these commands mean. Now, there's one prerequisite that needs to be satisfied, and that is the master should have at least 2 core CPUs, okay, and 4 GB of RAM, and your node should have at least 1 core CPU and 4 GB of RAM. So just make sure that this much of hardware is given to your VMs, right? If you're using Ubuntu or a Linux operating system, well and good, but if you're using a VM on top of a Windows OS, then I would request you to satisfy these things, okay, these 2 criteria. And I think we can straight away start. Let me open up my terminal first of all. Okay, this is my node. I'm going back to my master. Okay, yes. So first of all, if you have to start your cluster, you have to start it from your master's end, okay? And the command for that is kubeadm init. You specify the pod network flag and the API server flag. We are specifying the pod network flag because the different containers inside your pod should be able to talk to each other easily, right? So that was the whole concept of self-discovery, which I spoke about earlier during the features of Kubernetes. So for the self-discovery, we have like different pod networks using which the containers would talk to each other. And if you go to the documentation, the Kubernetes documentation, you can find a lot of options there. You can use either a Calico pod, or you can use a Flannel pod network. So when we say pod network, it's basically acronymed as CNI, okay, Container Network Interface, okay? So you can use either a Calico CNI or a Flannel CNI or any of the other ones. These are the 2 popular ones, and I will be using the Calico CNI, okay? So this is the network range for this particular pod, and this we'll have to specify over here, okay? And then over here we'll have to specify the IP address of the master. So let me first of all copy this entire line, and before I paste it here, let me do an if config and find out what is the IP address of this particular machine, of my master machine. The IP address is 192.168.56.101, okay? So let's just keep that in mind, and let me paste the command over here. In place of the master IP address, I'm going to specify the IP address of the master, okay, which I just read out. It is 192.168.56.101. And the pod network, I told you that I'm going to use the Calico pod, so let's copy this network range and paste it here. So all my containers inside this particular pod would be assigned an IP address in this range, okay? Now let me just go ahead and hit enter, and then your cluster would begin to set up. So it's going as expected. So it's going to take a few minutes, so just hold on there. Okay, perfect. My Kubernetes master has initialized successfully, and if you want to start using your cluster, you have to run the following as a regular user, right? So we have 3 commands which is suggested by Kubernetes itself, and that is actually the same set of commands that even I have here, okay? So I'll be running the same commands. This is to set up the environment, and then after that we have this token generated, right? The joining token. So the token along with the init address of the IP of the master, if I basically execute this command in my nodes, then I will be joining this cluster where this is the master, right? So this is my master machine. This just created the cluster. So now before I do this though, there are a few steps in the middle. One of those steps is executing all these 3 commands, and after that comes bringing up the dashboard and setting up the pod network, right? Mine is the Calico pod, so I'll have to set up the Calico pod, and then I have to also set up the dashboard. Because if I do not start the dashboard and this before the nodes, then the node cannot join, and I will have various other complications. So let me first of all go ahead and run these 3 commands one after the other, okay? Since I have the same commands in my text doc, I'll just copy it from there, okay? I'll say Control C, paste, enter, okay? And I'll copy this line. So remember, you have to execute all these things as regular user, okay? You can probably use your sudo, but yeah, you'll be executing it as your regular user. And it's asking me if I want to override the existing whatever's there in this directory. I would say yes, because I've already done this before. But if you are setting up the cluster for the first time, you will not have this prompt, okay? Now, let me go to the 3rd line, copy this and paste it here. Okay, perfect. Now I've run these 3 commands as I was told by Kubernetes. Now the next thing that I have to do is, before I check the node status and all these things, let me just set up the network, okay, the pod network. So like I said, this is the line, this is the command that we have to run to set up the Calico network, okay, to allow the nodes to join our particular network. So it will be copying the template of this calico.yaml file which is present over here in this docs. Okay, so hit enter, and yes, my thing is created. Calico cube controller is created. Now I'll just go back here and see, at this point of time I can check if my master is connected to the particular pod. Okay, so I can run the kubectl get nodes command. Okay, this would say that I have one particular resource connected to the cluster. Okay, name of the machine, and this role is master, and yeah, the status is ready. Okay, if you want to get an idea of all the different pods which are running by default, then you can do the kubectl get pods along with a few options. Okay, you should specify these flags, and they are all namespaces, and with the flag O specify wide. Okay, so this way I get all the pods which are started by default. Okay, so there are different services like etcd for cube controllers, for the Calico node, for the etcd master. For every single service there's a separate container and pod started. Okay, so that's what you can understand from this part. Okay, that is the safe assumption. Now that we know the cluster is ready and the master is part of the cluster, let's go ahead and execute this dashboard. Okay, remember, if you want to use a dashboard, then you have to run this command before your nodes join this particular cluster, because the moment your nodes join into the cluster, bringing up the dashboard is going to be challenging and it will start throwing errors. Okay, it will say that it's being hosted on the node, which we do not want. We want the dashboard to be on the server itself, right, on the master. So first let's bring the dashboard up. So I'm going to copy this and paste it here. Okay, enter. Great, my Kubernetes dashboard is created. Now the next command that you have to get your dashboard up and running is kubectl proxy. Okay, with this you'll get a message saying that it's being served at this particular port number. And yes, you are right now there. You can, if you access localhost, what was the port number again? Localhost, yeah, 127.0.0.1 is localhost. Okay, followed by port number 8001. Okay, yeah, so right now we are not having the dashboard because it is technically accessed on another URL. But before we do that, there are various other things that we have to access. I mean, we have to set. Okay, because right now we have only enabled the dashboard. Now if you want to access the dashboard, you have to first of all create a service account. Okay, the instructions are here. Okay, you have to first of all create a service account for your dashboard. Then you have to say that, okay, you are going to be the admin user of this particular service account, and you have to enable that functionality here. You should say dashboard admin privileges, and you should do the cluster binding. Okay, the cluster role binding is what you have to do. And after that, to join to that or to get access to that particular dashboard, we have to basically give a key. Okay, it's like a password. So we have to generate that token first, and then we can access the dashboard. So again, for the dashboard there are these 3 commands. Well, you can get confused down the line, but remember, this is separate from the above. Okay, so what we did initially is ran these 3 commands which Kubernetes told us to execute, and after that the next necessity was bring up a pod. So this was that command for the pod, and then this was the command for getting the dashboard up, and right after that run the proxy, and then on that particular port number it'll start being served. So my dashboard is being served, but I'm not getting the UI here. And if I want to get the UI, I have to create the service account and do these 3 things, right? So let's start with this and then continue. I hope this wasn't confusing, guys. Okay, I can't do it here, so let me open a new terminal. Okay, here I'm going to paste it, and yes, service account created. Let me go back here and execute this command where I'm doing the role binding. I'm saying that my dashboard should have admin functionalities, and that's going to be the cluster role. Okay, cluster admin, and then the service account is what I'm using, and it's going to be in default namespace. Okay, so when I created the account, I said that I want to create this particular account in default namespace. So the same thing I'm specifying here. Okay, dashboard admin created. Good. So let's generate the token that is needed to access my dashboard. Okay, before I execute this command, let me show you that once. So if you go to this URL, right, /API/v1/namespaces. Yep, let me show it to you here. Okay, so this is the particular URL where you will get access to the dashboard. Okay, login access to the dashboard, localhost 8001 API v1 namespaces /kubesystem/services/https Kubernetes dashboard :/proxy. Okay, remember this one. That is the same thing over here, and like I told you, it's asking me for my password, so I would say token, but let me go here and hit the command and generate the token. So this is the token. I'm gonna copy this from here till here. I'm gonna say copy, and this is what I have to paste over here. All right, so sign and update. Yes, perfect. So this is my dashboard, right? This is my Kubernetes dashboard, and this is how it looks like. Whatever I want, I can get an overview of everything. So there is workloads. If I come down, there is deployments. I have option to see the pods, and then I can see what are the different services running among most of the other functionalities. Okay, so right now we don't have any bar graph or pie graph showing you which cluster is up, which pod is up and all, because I have not added any node and there is no service that is running, right? So I mean, this is the outlay of the dashboard. Okay, you will get access to everything you want from the left. You can drill down into each of these namespaces or pods or containers, right? Now, if you want to deploy something through the dashboard, right, through the click functionality, then you can go here, okay? But before I create any container or before I create any pod or any deployment for that matter of fact, I have to have nodes because these will be running only on nodes, correct? Whatever I deploy, they run only on nodes. So let me first open up my node and get the node to join this particular cluster of mine. Now, if you remember, the command to join the node got generated at the master end, correct? So let me go and fetch that again. So that was the first command that we ran, right? This one. So let's just copy this and paste this one at my node end. This is the IP of my master, and it will just join at this particular port number. Let me hit enter. Let's see what happens. Okay, let me run it as root user. Okay, perfect. Successfully established connection with the API server, and it says this node has joined the cluster, right? Bingo. So this is good news to me. Now if I go back to my master, and in fact if I open up the dashboard, there would be an option of nodes, right? So initially now it's showing this master. Master is the only thing that is part of my nodes. Let me just refresh it, and you would see that even node-1 would be a part of it, right? So there are two resources, two instances. One is the master itself and the other is the node. Now if I go to overview, you will get more details. If I start my application, if I start my service or containers, then all those would start showing up here, right? So it's high time I start showing you how to deploy it. To deploy it using the dashboard, I told you this is the functionality. So let's go ahead and click on this create. And yeah, mind you, from the dashboard is the easiest way to deploy your application, right? So even developers around the world do the same thing. For the first time, probably they create it using the YAML file, and then from there on, they start editing the YAML file on top of the dashboard itself, or they create or deploy the application from here itself. So we'll do the same thing. Go to create an app using functionality, click functionality, you can do it over here. So let's give a name to your application. I'll just say Edureka demo. Okay, let that be the name of my application. And I want to basically pull an Nginx image. Okay, I want to launch an Nginx service. So I'm going to specify the image name in my Docker hub. Okay, so it says either the URL of a public image or any registry, or a private image hosted on Docker hub or Google Container Registry. So I don't have to specify the URL per se, but if you're specifying a Docker hub, if you're specifying this image to be pulled from Docker hub, then you can just use the name of the image which has to be pulled. That's good enough, right? Nginx is the name, and that's good enough. And I can choose to set my number of pods to 1 or 2. In that way, I will have 2 containers running in the pod, right? So this is done. And the final part is actually, without the final part, I can straight away deploy it. Okay, but if I deploy it, then my application would be created, but I would just not get the UI. I mean, I won't see the Nginx service. So that I get the service, I have to enable one more functionality here. Okay, the servers here, click on the drop down, and you will have external option, right? So click on external. This would let you access this particular service from your host machine, right? So that is the definition. So you can see the explanation here. An internal or external service can be defined to map an incoming port to a target port seen by the container. So Nginx, which would be hosted on one of the container ports that could not be accessible if I don't specify anything here. But now that I've said access it externally on a particular port number, then it would get mapped for me. By default, Nginx runs on port number 80. So the target port would be the same, but the port I want to expose it to, that I can map it to anything I want. So I'm going to say 82. All right. So that's it. It's as simple as this. This way your application is launched with 2 pods. So I can just go down and click on deploy. And this way my application should be deployed. My deployment is successful. There are 2 pods running. So what I can do is I can go to the service and try to access the UI, right? So it says that it's running on this particular port number 82153. So copy this and say localhost 32153. Okay, hit enter. Bingo. So it says welcome to Jenkins, and I'm getting the UI, right? So I'm able to access my application which I just launched through the dashboard. It was as simple as that. So this is one way of launching or making a deployment. There are 2 other ways, like I told you. One is using your CLI itself, your command line interface of your Linux machine, which is the terminal, or you can do it by uploading the YAML file. You can do it by uploading the YAML file because everything here is in the form of YAML or JSON. Okay, that's like the default way. So whatever deployment I made, right, that also those configurations are stored in the form of YAML. So if I click on view or edit YAML, all the configurations I specified, the default ones have been taken. So I said the name should be Edureka demo. That is what has been taken over here. That is the name of my deployment. Okay, so kind is deployment. The version of my API, it's this one, extension / v1 beta 1. And then under metadata, I have various other lists. So if you know how to write a YAML file, then I think it will be a little more easier for you to understand and create your deployment, because YAML file is everything about lists and maps. And these YAML files are always lists about maps and maps about lists. So it might be a little confusing. So probably we'll have another tutorial video on how to write a YAML file for Kubernetes deployment, but I would keep that for another session. Okay, let me get back to this session and show you the next deployment. Okay, the next deployment technique. So let me just close this and go back to overview. Okay, so I have this one deployment. Very good. Okay, so let's go to this. Yeah, so what I'll do is let me delete this deployment. Okay, or let me at least scale it down, because I don't want too many resources to be used on my node also, because I will have to show 2 more deployments, right? So I have reduced my deployment over here, and I think it should be good enough. Great. So let's go back to the kube setup, this document of mine. So this is where we were, right? We could check our deployments, we could do all these things. So one thing which I might have forgotten is showing the nodes which are part of the cluster, right? So this is my master. Yeah, so I kind of forgot to show you this kubectl get node. So the same view that you got on your dashboard, you get it here also. I mean, these are the 2 nodes, and this is the name and all these things. Okay, and I can also do the kubectl get pods, which would tell me all the pods that are running. Edureka demo is the pod which I have started. Okay, this is my pod. Now if I specify with the other flags, right, with all namespaces and with wide, then all the default pods which get created along with your Kubernetes cluster, those will also get displayed. Let me show you that also, just in case. Okay, yeah, so this is the one which I created, and the other ones are the default deployments that come with Kubernetes. The moment you install set up the cluster, these get started. Okay, and if you can see here, this particular Edureka demo which I started is running on my node 1 along with this kube proxy and this particular Calico node. So these 2 services are running on master and node, and this one is running only on my node 1, right? You can see this, right? The Calico node runs both on my node over here and on my master, and similarly the kube proxy runs on my node here and on my master. So this is the one that's running only on my node. Okay, so getting back to what I was about to explain you, the next part is how to deploy anything through your terminal. Now to deploy your same Nginx application through your CLI, we can follow these set of commands. Okay, so there are a couple of steps here. First of all, to create a deployment, you have to run this command. Okay, kubectl create deployment Nginx, and then the name of the image that you want to create. This is going to be the name of your deployment, and this is the name of the image which you want to use. So Control C, and let me go to the terminal here. On my master, I'm executing this command, kubectl create deployment. Okay, so the deployment Nginx is created. If you want, we can verify that also over here. So under deployments, right now we have 1 entry, Edureka demo, and yes, now you can see there are 2, Nginx and Edureka demo. So this is pending. I mean, it would take a few seconds. So in the meanwhile, let's just continue with the other steps. Once you have created your deployments, you have to create the service. Okay, you have to say which is the node port which can be used to access that particular service, right? Because deployment is just a deployment. You're just deploying your container. If you want to access it, like I told you earlier, from your from your host machine or all those things, then you have to enable the node port. If you want to get your deployments on your terminal, you can run this command kubectl get deployments. Okay, Nginx also comes up over here, right? If you want more details about your deployment, you can use this command kubectl describe. You'll get like more details about this particular deployment as to what is the name, what is the port number it's residing on, and all these things. Okay, let's not complicate this. You can probably use that for your understanding later. So once that is done, the next thing that you have to do is you have to create the service on the nodes. You have created the deployment, but yes, create the service on the nodes using this particular command kubectl create service and say node port. Okay, this means you want to access it at this particular port number. You're doing the port mapping 80 is to 80. Okay, container port 80 to the internal node port 80. Okay, so service for Nginx is created. And if you want to check which of the deployments are running in which nodes, you can run the command kubectl get svc. Okay, this would tell you, okay, you have two different services, Edureka demo and Nginx, and they are running on these port numbers and on these nodes, right? So Kubernetes is the one which got created automatically. Edureka demo is the one which I created. Okay, Nginx is again the one which I created. Kubernetes comes up on its own. I'm just specifying to you because this is a container for the cluster itself. Okay, so let's just go back here, and then yes, and similarly, if you want to delete a deployment, then you can just use this command kubectl delete deployment followed by the name of the deployment, right? It's pretty simple. You can do it this way. Otherwise, from the dashboard also you can delete it, like how I showed you earlier. Click over here and then you can click on delete, and then if you want to scale it, you can scale it. So both of these deployments of mine have one pod each, right? So let's do one thing. So let's just go to the Nginx service, and here let's try accessing this particular service. Localhost. Okay, perfect. Here also it says welcome to Nginx, right? So with this, you can understand that the port mapping worked, and by going to service, you will get to know on which port number you can access it on your host machine, right? So this is the internal container port mapped to this particular port of mine. Okay. Now, if not for this, if this doesn't work, you can also use the cluster IP for the same thing. Cluster IP is going to basically the IP using which all your containers access each other, right? So for your pod, you will have an IP. So whatever is running in your containers, that will again be accessible on your cluster IP. So it's the same thing, right? So let me just close these pages, and that's how you deploy an application through your CLI. So this comes to our last part of this video, which is nothing but deployment via YAML file. So for again deployment via YAML file, you have to write your YAML code, right? You have to either write your YAML code or your JSON code, correct? So this is the code which I have written, which is in YAML format, and in fact I already have it in my machine here. So how about I just do an ls? Yeah, there is deployment.yaml, right? So let me show you that. So this is my YAML file. Okay, so here I specify various configurations similar to how I did it using the GUI, or I did it using the CLI. It's something similar. It's just that I specify everything in one particular file. Here, if you can see that I have specified the API version. Okay, so I'm using extensions dot slash b1 or beta 1. Okay, I can do this, or I can just simply specify version 1. I can do either of those. And then the next important line is the kind. So kind is important because you have to specify what kind of file it is. Is it a deployment file, or is it for a pod deployment, or is it for your container deployment, or is it the overall deployment? What is it? So I've said deployment, okay, because I want to deploy the containers also along with the pod. So I'm saying deployment. In case you want to deploy only the pod, which you realistically don't need to, okay, why would you just deploy a pod? But in case if you want to deploy a pod, then you can go ahead and write pod here and then just specify what are the different containers. Okay, but in my case, it's a complete deployment, right, with the pods and the services and the containers. So I will go ahead and write other things. And under the metadata, I will specify the name of my application. I can specify what I want. I can put my name also over here, like Vardhan. Okay, and I can save this. And then the important part is this spec part. So here is where you set the number of replicas. Do you remember I told you that there's something called as replication controller, which controls the number of pods that you will be running? So it is that line. So if I have set 2 over here, it means that I will have 2 pods running of this particular application of Vardhan. Okay, what exactly am I doing here? Under spec, I'm saying that I want two containers. So I've intended a container line over here, and then I have two containers inside. So the first container which I want to create is of the name front end. Okay, and I'm using an Nginx image. And similarly, the port number that this would be active on is container port 80. All right, and then I'm saying that I want a second container, and the container for this I could rename this to anything. I can say backend, and I can choose which image I want. I can probably choose a HTTPD image also. Okay, and I can again say the ports that this will be running on. I can say the container port that it should run on is port number is 88, right? So that's how simple it is. All right, and since it's your first video tutorial, the important takeaways from this YAML file configuration is that under spec you'll have to specify the containers and yes, everything in JSON format with all the indentations and all these things. Okay, even if you have an extra space anywhere over here, then your YAML file would throw an invalid error. So make sure that is not there. Make sure you specify the containers appropriately. If it's going to be just one container, well and good. If it's two containers, make sure you indent it in the right way, and then you can specify the number of pods you want to give a name to your deployment, and mainly establish these rules. Okay, so once you're done with this, just save it and close this YAML file. Okay, so this is your deployment.yaml. Now you can straight away upload this YAML file to your Kubernetes. Okay, and that way your application would be straight away deployed. Okay, now the command for that is kubectl create -f and the name of the file. Okay, so let me copy this, and then the name of my file is deployment.yaml. So let me hit enter. Perfect. So my deployment, the third deployment, Vardhan, is also created, right? So we can check our deployments from the earlier command, that is nothing but kubectl get deployments. Okay, it's not get deployment.yaml, sorry, it's get deployments. And as you can see here, there is an Edureka demo, there is Nginx, and there is Vardhan. And the funny thing which you should have noticed is that I said I want two replicas, right? Two pods. So that's why the desired is two. Currently we have two, up to date is one. So okay, up to date is two. Brilliant. Available is 0 because let's just give it a few seconds. In 23 seconds, I don't think the pod would have started. So let's go back to our dashboard and verify if there's a third deployment that comes up over here. Okay, perfect. So that's how it's going to work. Okay, so probably it's going to take some more time because the container is just restarting. So let's just give it some more time. This could well be because of the fact that my node has very less resource, right? So I have too many deployments. That could be the very reason. So what I can do is I could go ahead and delete other deployments so that my node can handle these many containers and pods, right? So let me delete this particular deployment, Nginx deployment, and let me also delete this Edureka demo deployment of mine. Okay, now let's refresh and just wait for this to happen. Okay, so what I can do instead is I could have a very simple deployment, right? So let me go back to my terminal and let me delete my deployment. Okay, and let me redeploy it again. So kubectl delete deployment. Okay, so Vardhan, this deployment has been deleted. Okay, so let's just clear the screen and let's do gedit of the YAML file again. And here let's make things simpler. Let me just delete this container from here. Let me save this. All right, and close this. Now let me create a deployment with this. Okay, so Vardhan is created. Let me go up here and refresh. Let's see what happens. Okay, so this time it's all green because it's all healthy. My nodes are successful, or at least it's going to be successful. Container creating. Perfect. So two pods of mine are up and running, and both my pods are running, right? And both are running on node 1. Pods 2 out of 2. Those are the two deployments, and replica set, and then services, right? So it's Nginx, which is the base image which is being used. So well and good. This is also working. So guys, yeah, that's about it, right? So when I tried to upload it, maybe there was some other error, probably in the YAML file. There could have been some small mistake, or it could have been because my node had too many containers running. Those could have been the reasons. But anyways, this is how you deploy it through your YAML file. All right, so that kind of brings us to the end of this session, where I've showed you a demonstration of deploying your containers in 3 different ways: CLI, dashboard, and your YAML files. So on that note, I would like to conclude today's session. So this is Vardhan signing off from Edureka. Thank you and happy learning.